To calculate the instantaneous speed of a falling object using time data, what you need to know is two things. You need to know that velocity is the acceleration due to gravity times time, and you need to remember that g is 10 meters per second squared. So if we want to calculate the speed of an object that's been in free fall for 4 seconds, then what we're going to do is say v equals gt, which is 10 meters per second squared, times 4 seconds, which is going to give you 40 meters per second. We want the speed of an object in free fall for 11 seconds. That's going to be 10 meters per second squared times 11 seconds. And that is 110 meters per second. Okay, so when do we use this? We use this equation for a falling object. So when you get to the final, you want to make sure to know when to specifically use this information, because it's not going to tell you to use that, you just have to know to use that. To calculate the distance traveled, we have a new equation for that one. Okay, so the distance traveled, you're going to use this one. D equals 1/2 g times the time squared. Again, g is going to be 10 meters per second squared. That doesn't change. In all the problems, we're using everything in comparison to Earth, so that acceleration due to gravity is going to stay the same. So if we want to find the distance covered by an object in free fall for 5 seconds, we're going to say d equals 1/2. G is 10 meters per second squared. T is 5 seconds, and we have to square that. So we have 1/2 of 10, which is 5 times 5 squared, is going to be 125 meters. I would suggest just typing this just how it looks into your calculator. For the next one, it's for 8 seconds. So that's d equals 1/2 10 meters per second squared times 8 seconds squared, and then you're going to get 64 times 5 is 320 meters. And then for the last one, we want to calculate the time of free fall using velocity or distance data. So the minute you know that you have a free fall situation, right away you know that you have two equations that you need to think about. The two equations are either v equals gt or d equals 1/2 gt squared. So every single time that we're talking about free fall, you need to think about these two equations. So what you want to do, maybe once we hit this part of the test on that first day, get your equation sheet, and you might want to write on there free fall next to these two so that you know that that's coming for these goals. So an object in free fall has reached a speed of 40 meters per second. So I have v is 40 meters per second. And it wants to know how long it's been in free fall, so we're looking for the t value. Well, if I come over here, right, in this problem, I have v, g, and t, and I have those pieces. If I have v equals gt, and I want to solve for t, that means that 40 equals 10t, and if I divide both sides by 10, then t equals 4 seconds. And then for the next one, we have an object has fallen for 18,000 meters. That's a distance. It wants to know how long it's been in free fall. Well, if I'm looking for distance, I know this equation is not going to help me, so I have to use this one. So d equals 1/2 gt squared. So d is 18,000 equals 1/2 of 10 times t squared. So that means 18,000 equals 5t squared. I need to divide both sides by 5. So t squared equals, well, 18,000 divided by 5 is 3,600, but this is t squared. So I'm going to take the square root of both sides. When you do that, you get t equals 60 seconds.